Hey guys, this is Mr. C, and in this video we're going to be talking about something called function notation. So first thing I'm going to do is I'm going to put a couple equations up here. I'm going to put y is equal to 3x plus 2, and I'm going to put y is equal to 2x minus 9. Here I have two linear equations. They're both lines, and it turns out that they're both functions. The issue though is what happens if I ask a student or ask somebody, what does y equal? And so if I have both of these sitting here, both with y right there, and I say, what is y equal to? There's going to be confusion because it could be this or it could be this, right? And so what we need to do is we need to nail it down. When I say, what is y equal to? We should really be able to nail it down as to which one I'm talking about. Otherwise, we really don't know. So what we do is we use something called function notation. And so function notation has an f, and the f stands for function, in some parentheses, and then x equals 3x plus 2. And so what I've done is I've just taken this equation, I've named it f of x. And so function of x, and we usually use f, but we can use other letters too. If I use this function notation, it's really good because now I can say, okay, what is f of x equal to? And now the person can clearly say 3x plus 2 and won't say 2x minus 9. Now I've got another one sitting over here though. So what do I do with this one? I want them to be different. So if I want them to be different, I'm gonna have to name this one differently. And so instead of f of x, and here's your variable right here, instead of f of x, I'm gonna name it something else, something like maybe g of x equals 2x minus 9. So now when I refer to these two guys, these two lines, I'm gonna say f of x and g of x. But really, f of x is just y and g of x is just y. Those are just the y values. So when you see these things, these function notations, just remember, these are just the y values, the output, right? That's just the dependent variable. And so by naming it this, I can do two things. Number one, I can go ahead and I can call them something. And so I can differentiate between these two. The other cool thing I can do is I can, let's take this one for instance. I can say, what is f of 1? F of 1 means you take the 1 and you plug it into the right-hand side of the function wherever you see the variable. Well, there's only 1 in this case. So f of 1 would be 3 times 1 plus 2. Now I'm going to go ahead and get a value for it, a y value. So f of 1 is equal to, and I'll keep dropping this down to show you, 3 times 1 is 3 plus 2. And so f of 1 is equal to 5. Now what this tells me, this is some extra information. This actually gives me an ordered pair because when the x value is 1, the output is 5. And so previously we had y sitting there. This is still a y value. And so on the coordinate plane, 1, 5 would be a point on that line right there. And you could do that for as many values here as you want. So why did I choose 1? I just felt like it. You can choose any value you want as long as it's in the domain. And so we're going to be getting some practice with plugging some numbers in here, just random numbers, nothing special, and then figuring out what the output is. And then we'll have an ordered pair. So that's the groundwork there for what we're about to do. And we have some examples. And so this one says, if f of x is equal to 7x plus 2, then what is f of 4? Well, I'm going to take that 4 and I'm going to plug it in right there and right here. Now, sometimes people don't write f of 4. I'm going to, but sometimes they don't write it here. They just go ahead and figure it out over on this side. I'm actually going to write it out. F of 4 is equal to 7 times 4 plus 2. There's only one place to plug it in, so this one's going to be pretty easy. So what's f of 4 equal to? 7 times 4 is 28 plus 2. And we just use our order of operations. 28 plus 2 is 30. And so that's what f of 4 is. So finally, f of 4 is equal to 30. All right, great. That gets me credit on the test. What does that mean? Well, that means that the ordered pair 4, 30 is on that line right there. And that is a line, that's linear. And so when x is 4, y is 30, or the output is 30, And so that ordered pair is on that line. And you can do that with any value you want over here. As long as it's a line, we don't have a problem with that. As long as it's not a vertical line. All right. So we have another linear function. And I like to use f of x as much as possible, but you could use anything. You could use g of x or a of x. You're going to see all kinds of stuff. V of x for volume, all kinds of functions. All right, this time I have -2. So f of -2 is equal to 3 times -2 minus 5. So students don't usually struggle with this part. What they struggle with is the negative numbers when they plug it in. So let's see what happens. 3 times -2 is -6. Take away 5. I owe somebody $6, then I owe them 5 more. That means I owe them a total of 11. And so it's -11. So f of -2 is equal to -11. So if I graph that line right there, the ordered pair -2, -11 is going to be on that line. And so you can actually graph a line this way by plugging in a couple of values of x, putting them on a coordinate plane, and then drawing a line through them. It's easy to graph a line this way. All right, this one, I want f of 3. So now I'm going to put a 3 in right here and right here, just for fun. So f of 3 is equal to 6 minus 8 times 3. All right, so again, we're just doing our order of operations. 6 minus 8 times 3 is 24. So now we have 6 take away 24, which should be -18. And that's what f of 3 is. All right. So we're evaluating functions. That's what this is called, using function notation. We're going to get fractions and we're going to get these weird stuff from time to time. So I'm going to give you some of those examples. -6, -6. When I plug it in for that x right there, nothing's really happening over here. I'm just showing what f of -6 is when x is -6, because I get that extra piece of information. F of -6 equals 2/3 times -6 plus 2. You can do this however you want. I've got my own special ways that I deal with fractions, and I'll tell you that my ways are not everybody's ways, but it's my way. If I look at this, a couple ways I could do it. 6 times 2 is 12, divided by 3 is 4. You could do it that way. I know all of this is going to be -4. Or you could do 6 divided by 3 is 2, times 2 is still -4. I'm going to go ahead and I'm going to do it the way that most students are okay with. 6 times 2 is 12, divided by 3 is going to be -4. So let me actually write that in this color. So -4 plus 2. And now if you don't like to do it that way, you can always go out to the side and calculate it this way. You could always do that. And so you would get -12 still over 3, which is still going to be -4. So -4 plus 2 is -2. And that is my value for f of -6. All right, so here we don't have a linear equation anymore. We have, or a linear function, we have a quadratic. And so now you have a little square there. So that clues you in that it's quadratic. So we're going to plug a -2 in here and here, just to kind of show you how this works. So f of -2, and most teachers are going to have you do this a lot later in Algebra 1 and in Algebra 2 also. When I plug that -2 in, though, I must use parentheses, especially for you calculator people out there. Got to use parentheses. All right, order of operations. -2 squared is +4, take away 9, and 4 take away 9 is -5. So what this means is that on this parabola, is what that's called, the graph of a quadratic is called a parabola. On that parabola, that point is going to be on there, -2, -5. Very handy information. Okay, so we've got another quadratic, just to kind of show you how this works. This time we have to plug the 3 into 2 places. So here, here, and here. All right, so let's see how that works. F of 3 equals Now that negative is outside that x squared. That's going to be critical. That does not go in parentheses, that negative. The 3 does though. I'm going to put that in parentheses. So when in doubt, use parentheses. Minus 2 times 3 plus 3. All right, order of operations, I got to do that first. 3 squared, not negative 3 squared, but just 3 squared. So the negative is still going to be there after you square that 3. Critical. 3 squared is 9. Now I can do this, negative 6 plus 3. All right, let's keep it going. Negative 9 take away 6 is negative 15 plus 3. And negative 15 plus 3 would be negative 12. So the point 3 comma negative 12 is on that parabola. And our last example, we have one more quadratic to show you. 2 places to plug it in. So 2, 2, and 2. This time we have a coefficient in front of the x squared is a negative 16, so we got to be careful of that. So f of 2 equals negative 16. Now parenthesis 2 squared plus 32 parenthesis 2. All right, so let's go ahead and take this slowly now. Order of operations, 2 squared is 4. So negative 16 times 4 plus, now we can do the 32 times 2 because that's separate from this because of the plus sign right there. 32 times 2 is 64. Not a problem. Negative 16 times 4 is actually a negative 64, isn't it? And negative 64 plus 64 is going to give me a final value of 0. Now, you're going to learn later that when this function is equal to 0, that is extremely important to know that. That's going to be an intercept and x-intercept, and that is something that we're going to need to know later. So it's going to happen sometimes, and sometimes it won't. Just depends on whatever value you plug in for your domain, for your x right there. So that's it for function notation. Make sure to like my video and subscribe to my channel, and we'll see you guys later. Bye.